This is R.D. Sharma Solution, Class 12, Chapter 6, Determinants, MCQ Multiple Choice Questions. Now this question where D sub K, that is the subscript, and we have a determinant, and when we sum these, or you can say K goes from some 1 to N, and we start adding this D determinant 1, then we put 2, then we put 3, and we keep on adding it like D1, D2, D3. K, in place of K you have to replace 1, 2, 3 like that. And if this is equal to 48, then what will be the value of N so that this addition is equivalent to 48? So let me resolve these first, and then we'll try to solve this. And these are different rows, so we have 3 rows and 3 columns. So what we'll do is, first we'll do row 2, we'll change row 2 to row 2 minus row 3. I'll show you how this will be done, row 2 minus row 3. So this will be 2k minus 2k plus 1. First one I'm showing you, just to know that how it will be done. So it will be 1. So the first element of the second row will be 1. Then we have other values. Okay. For example, row 2 minus row 1 is n square plus n plus 2 minus n square. So n square will get cancelled. And what will be there? It will be only 2 will remain. N square plus n plus 2 minus n square. So n plus 2 will remain. Right? Now coming to the third one, that is R2 minus R3. So n square plus n minus n square minus n minus 2. So minus 2 will remain. All these are very important because the later discussion will involve this. Now second step is to change the row 2 to row 2 minus row 1. The row 2 to row 2 minus row 1. So we have this 1 and n. What was remaining? 1, 1, 1, 1 n plus 2. 1 n plus 2 and minus 2, and the third row is 2k minus 1 n square and n square plus n plus 2. Now we are applying R2 minus R1. R2 will be changed to R2 minus R1. Well, let us see what will happen. So this row 2 minus row 1 we are doing, 1 minus 1 will be 0. N plus 2 minus n will be 2, and this is n plus 2 minus n, that is going to be 2, and then minus 2 minus n, this will be minus 2 minus n. Okay, the final thing which will come after doing R2 minus R3 and giving it to R2, and R2 minus R1 giving again back to R2. So this D sub K, why K? Because K is a variable here. So what will remain? 1 and n. Second we already changed. So let me just write that value, which is 0, 2 and minus 2 minus 1. 0, 2, minus 2 minus n. Then we have the third row. It will be 2k minus 1, n square plus n plus 2. So D sub k. Now when we add it, when we do this sigma here, so k equals 1 to n we have to do. That means we'll put k as 1, whole determinant. Then we'll put k as 2, k as 3, and then we go on and on till this k is n, and we add them and equate it to 48. I hope you got the idea. K is going to vary. Other value remains the same. So the expression will be in terms of n. Because k you are actually changing the value. So I am writing D sub 1. In place of k we are putting k as 1. It will be 1, 0 and k is 1. So 2 into 1 minus 1, that is going to be 1 here. And rest this n, this will be like this. Only k will be 1, okay? Rest all will remain same. Now we have to add it with what? Because now k has to be put in as 2, then 3 like that. So I'm now placing in place of k equals 2. So 1, 0, k is 2. So 2 to the 4 minus 1. And that is going to be 3. N to n square, n minus 2 minus n, and n square plus n plus 2. So this is going on. This goes up till n. So this final value will be actually 1. N. It will be 2n. K will be 2n minus 1. That is the only replacement here. Okay. Now let us compute this first one. And you will see an analogy here. Only this first column we are going to use, means the first column we are going to open only the things which will have the analogy you will just see. So I am opening the first one with 1, 0, 1. So 1, this will come, then 0 I am not writing. It will be minus 0 something, I am not writing. And then we have plus 1. And then that will be n2 and n minus 2 minus n. Minus 2 minus n. Okay. Now when we compute this, what are you going to get? 2 into n square plus n plus 2 and minus minus will become plus. So it will be plus n square into 2 plus 1, 2 plus n. This is not minus, this is plus, so I'll just change it. Plus the next part, plus 1 into, it will be minus 2 minus n into n and plus multiplied by minus 2n. Now this we have got when we put n as this k as 1 and the first determinant we have opened. Now the second determinant when we open, everything will come same. That is the first 1 into something, because we are opening it using first column, 1, 0, 3 will be there. So first thing will remain like this, 2 n square plus n plus 2 and plus n square 2 plus n. This is not negative, this is plus. I'll just change it in a while. Now this is analogy. You have to see the analogy, how they are similar. So this will be same thing. There will be 0 also, 0 multiplied by something, I'm not writing it. It will be same, plus n square 2 plus n. As I just suggested, it is not minus, plus, I'll just change it. Plus, now previously it was 1 and now it will be 3. 3 into this 3n and then minus 2 minus n and minus 2n. This will be. So 1, 3, next will be 5. 2k minus 1, if you put k as 3, 3 to the 6 minus 1 is 5. It will be 2n square plus n plus 1 plus n square 2 plus n and plus 5n. Same thing I'm writing. Minus 2 minus n and minus 2n. Now you see, this is k equals 1, this is k equals 2, this is k equals 3. So this will go on and on till n. When you put k equals n, this will go on and on. Right? So what will be the last one? This will remain same, it will not change. 2n square plus n plus 1 plus n square 2 plus n plus 1, 3, 5 and this will be n. So n minus 2 minus n minus 2n. Now when we add them, this also have to be added because there is a sigma. If you add 1, 1, 1 n times, the result will be n. So when you do this, if you add anything which is similar n times, so that summation will be n times of that particular single value. So this whole will be 2 into n square plus n plus 1 plus n square 2 plus n will be n times 2, same thing, just multiplied by n. So 2 n square plus n plus 2. Then we have plus, as I said, this is not negative, I'll just change it to plus. This will be plus n square 2 plus n, right? So let us do it. I'm just rechecking it so that, as I said, since it is when we open this with 1, the first one, it was actually minus came outside and we made it as plus, right? Okay. So this is a cross multiplication simply and plus will come. So as I was just suggesting, the same value, if it is going for n times, or if we are adding it for n times, n times, the result will be single value multiplied by n. Okay, this is the first value. Now coming to the second part. The second part is 1, if I take this n into minus 2 minus n minus 2, and this if I take common, and if we add all of these which you see here, so I'm just taking this and then I'm taking this common also. So what will remain? 1 plus 3 plus 5 till n. 1 plus 3 plus 5 till n. And the summation of 1, 3, 5, all the odd numbers, 1, 3, 5, odd natural numbers you can say, it is nothing but n square. So we can replace this 1 plus 3 plus 5 till n as n square. So I'm replacing it by n square. Okay, this whole has come. Now can you open this? Now you just have to open all of these. So when we open this, there will be some addition, there will be some cancellation, there will be some combination collection. I hope you will be able to do. I just don't have enough space. So everything you have to multiply, like n square, I'm showing it. N square with 2 and then n square with also inside whatever you see here. So multiply and just resolve. So what I'm trying to give you here is, I'm just clearing it. And the final thing I'm going to give you, the final will be 2n square plus 4n. So let me just show you here. When you open this, I told you 1 plus 3 plus 5 plus 7 plus n was n square. And we just put k equals 1, then 2, then 3, like this goes till n, and we add it. So when we open this, we get 2n square plus 4n. So 2n square plus 4n is equal to 48. 2n square plus 4n minus 48 equals 0. Just divide it by 2n square plus 2n minus 24 equals 0. Now 6 4 is 24. So this 2 can be written in terms of 6 and 4. N square plus 6n minus 4n minus 24 equals 0. So n you can take common, n plus 6, and minus 4 you can take common from here, and that will come as n plus 6. Here n plus 6 minus 4 n plus 6 equals 0. So n plus 6 and n minus 4 will be the factor. Either n minus 4 is equal to 0, that is n is 4, or n plus 6 equals 0 and n equals minus 6. But since n cannot be minus 6, it is going from 1 to n, right? So we discard this n equals minus 6 value. We will take n equals 4, right? N is equal to 4. Now this one, we have just did a question like this in this exercise. So this expression be an identity in x where a, b, c, d, e are independent of x. Then the value of e is, so what is the value of the constant basically? Everything is there from x to the power 4 till x to the power 0. And what is the constant x to the power 0? That is e. So what we'll do here is we'll just open this determinant, or we'll solve this determinant. And since we are not applying any properties, I'll show you here only. I hope you'll be able to do, because this we have done a number of times. So the final expression, I hope you'll be able to do it. And we are opening it using the first row. So first row is x square plus 3x, x minus 1, and x plus 3 we will use. And they will be multiplied by the minor, their minus, their respective minors. So the final thing is that you will get an expression. I hope you will be able to do this. This is the final expression. Now I want you to compare it with ax4, bx3, and cx square and dx plus e. So I'm equating it using this. So when you equate this, see x to the power 4, so a is minus 7, x3, b is 22, c is 32, d is 27. What is constant? Constant is 0. There is no constant term here. So the answer is 0. B is the correct answer. Using the factor theorem, it is found that a plus b, b plus c, c plus a are the three factors of determinant this. The other factor in the value of the determinant is. So in order to solve this, we have to use a plus b, b plus c, c plus a. So everything we have to write in terms of this a plus b plus c plus a, because they are already given as the factors of this determinant. I hope you got the idea that a plus b plus c plus a is important. So a plus b, let us say, because a and b is there, let us say it is 2c. It is twice. You will just know why we are writing it as 2c. What is b plus c? B plus c, we can write it as 2a. B and c on the other left hand side, a will on the right hand side. Why I am writing it, you will just know. Now what about a plus c? So a plus c will be 2b. And this a, b, c on the right hand side, we have just taken it capital just to have a difference between the smaller ones and the capital ones. Right. Okay. We'll use it later. So I am using the left hand side and the right hand side and adding them. It will be a plus twice a, twice b, twice c. Right also twice a, twice b, twice c. So just take 2 common from there. So a small a plus b plus c will be equal to capital A plus b plus c. Right? Now we can write a in terms of this. What is a? A plus b plus c minus b plus c. Right? We can write b and c gets cancelled. What is a plus b plus c? We just saw that it is capital A plus capital B plus capital C. So capital A plus B plus C minus, what is B plus C? I just told you it is twice A. Assume it to be twice A. So A plus B plus C minus 2A, A gets cancelled. It will be B plus C minus A. So B plus C minus A, this is for A. Similarly, we can find out B and C. B is C plus A minus B, and C will be A plus B minus C, all in capitals on the right hand side. Now you see, this we have started, and we will write this in terms of capital ABC. Right? So first one is minus 2A. So I'll just show you how to do this minus 2A so that you will be able to do by yourself minus 2B and minus 2C. And then B plus A plus B, C plus A, we already imagined it. We have already said this is what 2C, 2B, 2A will be. So minus 2A I'm going to just show you. Minus twice, what is A? In place of A, you can write B plus C minus A. Now multiply it here inside. It will be minus 2B minus 2C and plus 2A. So it will be 2A minus 2A minus 2B minus 2C. Now you can take 2 common. 2 was already common. So this is twice A plus B minus C. So this is how we'll write this. Minus 2A is A minus B minus C. Twice of this. And in place of this minus 2B, you can write 2B minus 2C minus 2A. In place of minus 2C, you can write 2C minus 2A minus 2B. Right? Okay. In place of minus 2A minus 2B minus 2C, we have written all of it. In place of B plus A, C plus A plus B, we will have to write 2C, 2A, 2B. Okay. Now, why we require it? Now you see, in row or column, you can take 2 common. You get 2 common either from the rows or the column. So 2 into 2 into 2, that is going to be 8. So 8 you have taken common. So this whole will change column 1 to column 1 plus column 2 and column 2 to column 2 plus column 3. So column 1 will be changed to column 1 plus column 2, that is this C. If you add A minus B minus C, C gets cancelled, A minus B. If you add C is B minus C minus A, C gets cancelled. Similarly here, C2 plus C3. A plus C minus A minus B will be A gets cancelled, C minus B. So finally what you got? We have got this one. Now we'll apply row 1, row 2 will be changed to row 1 plus row 2. And row 3 will change to row 2 plus row 3. We already changed column 1 to column 1 plus column 2, column 2 to column 2 plus column 3. Here we are going to change row 2 to row 1 plus row 2 and row 3 to row 2 plus row 3. So what do you get? Finally, final value I'm going to tell you. A minus this is the final value, and 8 of course was there. We just wanted maximum zeros here actually. Now what we do here is we open it using the first column. So a minus b, 0 I'll leave, and this will be twice of b. So a minus b and twice b. So a minus b, this just write the cofactor, no, minor here. So when we just open this, we get 32 into a plus b plus c. 32 into a plus b plus c. So 16 we have taken, and 2 will come outside. Only ABC will remain 32. Capital A, capital B, capital C. But a capital A, capital B, capital C, this you have chosen, you have written. The question is only asking about small a, b, c. So now we'll replace capital A by what? Capital A by B plus C by 2. Capital B by A plus C by 2. Capital C by A plus B by 2. 32 was there, so we have 2 in the denominator, 8, so 8 4 is 32. And what we got? A plus B, B plus C, CA. A plus B, B plus CA was already the factor of the determinant. It is already given in the question. So we have 4 remaining. So 4 is the other factor of the determinant. Got it? It's a tricky question. If it will come in 5 marks, I hope. If A, B, C are distinct, then the value of x satisfying this is equal to 0. So now you see, if we put x equals say 0, if you see x equals to 0, this matrix or the determinant is going to be skew symmetric. I am putting x as 0. So 0 minus a minus b, a 0 c, and b minus c 0. B minus c 0. Okay. Now this we got when x is 0. This one, this particular matrix you can call it, or a determinant you can call it. Determinant is actually the value of the matrix. So we can call it as matrix also. Now this matrix, if you take the transpose of this matrix, it will be the negative of A. That means that this matrix is a skew symmetric matrix. That is, if you take the transpose, A transpose, it will be negative A. Let us see. Let us row and column I am just changing. 0 minus A minus B, this I am making as the column. So 0 minus A minus B. A0C I am making as a column, A0C. B minus C0 I am making it as a column. And now let us take negative common from here, negative 1. So when we take negative sign, it will be 0 minus A minus B. This will be A0C. This will be minus B C0. Minus B minus C. B minus C0. So A transpose is equal to negative A. So what does it mean? Skew symmetric. It is skew symmetric. And when you know in its skew symmetric matrix, if it is of say 3 by 3 order, if it is odd, then the determinant will be 0. So the determinant of this matrix is 0 because of it. Okay. Okay, this question we'll take in the next discussion. Till then, thank you so much. Take care of yourself.